Welcome to Mission APSC AZ YouTube channel. Today we'll going to discuss about one interesting topic of soil mechanics, that is effective stress and quicksand condition. This particular topics has great weightage in case of APSC assistant engineer and junior engineer exam. Every time some questions are framed from effective stress and quicksand condition. I'll try to discuss all the aspect of effective stress and quicksand condition in this lecture. If you like my videos, then please subscribe my channel and also do watch till the end of the lecture. So I'll use English as well as Assamese for discussion. So effective stress and quicksand condition, it was the key হয় basically. So we'll discuss conceptually what do we mean by the quicksand condition, what are what the formulas which we require to solve an equation in APSC exams or any other competitive exam in case of civil engineering, and what is the effective stress. This also we'll try to discuss in this video. Okay, যদি আপোনালোকে চেনেলটোত নতুনকৈ আহিছে দেন প্লিজ চেনেলটো লাইক কৰিব, শ্বেয়াৰ কৰিব। যিসকল চিভিলৰ ষ্টুডেণ্টছ আছে, যিসকলে বিটেক পঢ়ি আছে বা ডিপ্ল'মা কৰি আছে, আৰু যিসকল এক্সপিৰিয়েঞ্চ হয় সকলোলৈকে এই চেনেলটো আপোনালোকে শ্বেয়াৰ কৰিব। See, here it is said that soil is a multi-phase system. So now the question arises, what do you mean by multi-phase system? If you see in real life, the soil contains not only soil particles or the solid particles, it also contains air and it also contains water. That means soil is a mixture of basically the soil particles or the solid particles, then the voids, and that voids are filled up with water or air. That means soil has three phase system. One is air, another is water, and another is solid particles. So to perform any kind of analysis, we must understand the stress distribution. যদি আমি analysis কৰিব যাওঁ soilৰ ওপৰত stressটো কেনেকৈ আহে, we have to know the stress distribution, right? So stress distribution, how the stress are distributed inside the layer of the soil, that is important. Okay, so to understand the concept of effective stress, suppose we are assuming a structure where suppose a footing. So let me draw so that you can clear the concept. Okay, so suppose I'm trying to draw one footing. Suppose we have one building. Okay, suppose we have one building. Let me try to draw. See, suppose এটা আমাৰ footing আছে. So from that footing, suppose a load here. So this load will be distributed to the soil mass, right? So I am unable to draw the figure because my digital pad is not working. So here you can see that the soil must support those stress at the point to point contact. So কি হয়, soil mass এ সদায় কি কৰে, point to point contact the stress transfer কৰে, right? So soilৰ যিবিলাক point to point contact হয় soil particular মাজত, so সেই point to point contacts বিলাকৰ মাজেৰে কি হয়, soil particles এ নিজৰ stress বিলাক transform কৰে from one point to another point. Okay, so if you see the figure, so here you can see one figure. See here, suppose আমি এর কারণে টোটাল স্ট্রেস উলিয়াব গৈ আছো, এর কারণে টোটাল স্ট্রেস উলিয়াবৰ কাৰণে আমি কি কৰিব লাগিব, we have to determine basically the weight which is experienced due to that particular water table, that is H, and the weight which is experienced by the this particular A due to the height HA minus H. That means ইয়াৰ পৰা আমি যদি যাওঁ ইয়ালৈকে, that particular height আমাৰ কিমানটো weight আছে soil. So if you determine the total stress, আমি কি পাম, H into gamma W. That means the weight of water, that is this is H and gamma W is the unit weight of the water, plus কি হ'ব, HA minus H, that means this distance into gamma saturated. Gamma saturated is basically the saturated unit weight of the soil, right? So next we'll move the our main topic, that is effective stress. We can determine the total stress, no doubt. Now we have to discuss about the effective stress. So for effective stress, when the sigma is, suppose sigma to amar hoise ki total stress which is applied by the soil by its own weight. As we go deeper in the soil mass, the stress increase. So if you go to the deeper in the soil mass, the stresses increase. Suppose in a swimming pool, as you go deeper, the stress of the weight of the water increases, right? So in case of swimming pool, if someone experience যদি কোনোবাই সাঁতুৰিছে, so তেওঁ গম পাব যে যদি আমি যিমান তললে গৈ থাকো, the weight of water, যিজনে সাঁতুৰে তেওঁ experience কৰে যে weight of water টো বহুত বেছি যেন লাগে যিমান তললে তেওঁ গৈ থাকে, right? Similar phenomena happen in case of effective stress. The soil which carries stress in two ways. A portion is carried by the water. Okay, so soil actually দুটা প্ৰকাৰে stress carry কৰে. First is এটা portionৰ stress টো water লৈ থাকে. So soilত যিহেতু তিনটা part আছে, solid, liquid and void. So this liquid part also carry some loads, right? আৰু some portion of the load will be carried by the solids at their point of contents, right? So see, the sum of vertical components of the forces at their point of contact per unit cross-sectional area is called effective stress. So আমি যদি water load খিনি আঁতৰাই দিওঁ, if you exclude the water load, the load which is carried by the water, then we are left with only the contact point load, right? You can see in the figure these are the contact point loads, right? So that means these loads, no doubt they will carry by the soil grains only, not the water. So if you try to determine somehow the load which is carried by the the load which is carried by the particles or the soil particles or the solid particles or the point of contact, this is known as effective stress. That means we have to deduct the load or deduct the load carrying capacities which is taken by the water. Okay, that means soilot amar duta part asile, eta asile water aru eta asile apunar soil particle or solid particles. যদি আমি water stress to আঁতৰাই দিওঁ, water যিমানটো stress লৈছে সেইখিনি যদি আঁতৰাই দিওঁ, only we are interested about the soil particles stress, then that soil particle stress is known as effective stress, right? So the sum of vertical component of the force over the area is the effective stress. So effective stress is basically the sum of vertical force at the point of contact. So here, so we have to deduct the water pressure, that is HA into gamma W, which is stress due to water. So যিখিনি আমাৰ water লৈ আছিলে সেইখিনি we have to deduct, and that HA into HW is basically known as the pore water pressure, right? Pore water pressure is the pressure which is generated inside the liquids, right? So hey, pore water pressure খিনি যদি আমি deduct কৰি দিওঁ from the total stress, if we deduct sigma minus u, then we will get the effective stress. The formula is effective stress is, that's why sigma equal to sigma dash. That means total stress is a function of two parts. First function is sigma dash. Sigma dash is nothing but effective stress, and second is pore water pressure. Okay, so or if you determine the sigma dash effective stress, then you can write as total weight minus total stress minus pore water pressure. So now we'll move to the quicksand condition. Suppose when the flow takes place in an upward direction, the seepage pressure also acts in the upward direction and the effective pressure is reduced. Suppose এনেকুৱা এটা condition হৈ আছে, আমাৰ waters বিলাক তলৰ পৰা ওপৰলৈ আহি আছে, তেতিয়া কি হ'ব? Obviously যেতিয়া water pressure টো ওপৰলৈ আহি থাকিব, obviously the effective pressure is reduced. Why the effective pressure is reduced? We can see in this expression. So if the water pressure is increased, okay, if the u value is increased, suppose u to amar bahi bahi goi ase, so tetia ki hobo? Sigma dash or value to obviously komi goi thakibo, right? Effective stress to komi goi thakibo. So hetue koise So effective pressure to amar coming gese. If the seepage pressure becomes equal to the pressure due to submerged weight of the solids, যদি আমাৰ যেটো seepage pressure generated হৈছে হেতু যদি submerged weight of the solid or হইতে একে হৈ যায়, the effective pressure will be reduced to zero. আৰু কেতিয়াবা এনেকুৱা এটা কন্ডিশন হৈ যাব যে effective pressure টো আমাৰ কমি আহি আছিল এটা সময়ত যেতিয়া আমাৰ pore water pressure ৰ লগত total stress ৰ value টো same হৈ যাব, at that time the effective stress of the soil is zero. Since it is a effective stress, যেতিয়া soil effective stress to zero হৈ যাব, তেতিয়া কি হ'ব, the soil unable to carry its loads, right? So তাতে যদি আমি সেই তেনেকুৱা এটা particular soil ৰ ওপৰত যদি আমি থাকো, then obviously will go inside the soil because that soil has no shear strength, কোনো ধৰণৰ strength নাথাকে soil টোৰ. In such case, to move up the direction of flow, this phenomena of lifting soil particle is called quick condition or boiling condition. So আপুনি দেখাত আপোনাৰ গ্ৰাউণ্ডৰ নিচিনাই লাগিব কুইকচেণ্ডৰ য'ত কুইকচেণ্ড থাকে. But once when we apply some loads, suppose আমি এটা মানুহ suppose তাতে খাৰা হৈ গ'ল, so তেতিয়া কি হ'ব, obviously he will sink to that particular soil because this soil doesn't have any effective stress, and effective stress is the only driving stress which the soil can bear, right? So if you derive the expressions of effective stress in case of quicksand condition, you can derive as, so sigma total stress is obviously gamma saturated into the length of the or the height, that is L, minus pore water pressure is basically gamma W into HW1, that is water column height. So if you deduct it, if you derive it, then you can if you substitute effective stress becomes zero, then we'll get one expression gamma dash L is equal to gamma dash I. That means we'll get one value I is equal to gamma dash into gamma W. And if you substitute the value of gamma dash, that is gamma submerged and gamma W, then we can get one expression G minus 1. Okay, we can get one expression G minus 1 minus 1 plus I, right? So that is basically the formula. So আমাৰ ইয়াতে কি হ'ল, sigma dash আমি ফাইন কৰি আছিলো sigma minus u. So ইয়াৰ যেটো sigma হয়, that sigma is basically কি হয়, that sigma is nothing but total stress. This is total stress, তাৰ লগত আমি pore pressure টো minus কৰি দিলো. So total stress is basically gamma saturated. Gamma saturated is basically the summation of gamma submerged plus gamma W, right? And the suppose length of the path is L minus gamma W. Okay, suppose water head is L plus H. Okay, so if you deduct that, you will get one particular expression, that is gamma dash L minus gamma W H. Okay, but if you divide it by L, then you can get gamma W IL, right? So from there, if you equating effective stress 0, then we can get the I value as gamma W is gamma W. So if you substitute the value of gamma dash and gamma W, then you can get one important expression. Try to remember this expression, IC is equal to G minus 1 1 plus E, right? So hey expression to মনত ৰাখিবলৈ try কৰিব. Okay, then we'll move to the next slide. So what are the points we have to notate for quicksand condition? First point is quicksand is not a type of sand. বহুতে এটা mistake কৰে কি quicksand sand হয়. No, it is a condition. So য'ত effective stress 0 হৈ যায় আৰু সেই কাৰণে effective, so সেই কাৰণে ইয়াক hydraulic condition বোলে. A sand soil which becomes quick when the flow is upward under the hydraulic gradient which reduce the effective stress is 0. সেইখিনিয়ে কৈছে in the typical sand soil the critical hydraulic gradient is 1. So generally critical hydraulic gradient আমাৰ 1 হয়. Quicksand occurs mainly in fine sand. Quicksand আমাৰ generally fine sand ত occur কৰা হয় quicksand, right? So high artesian pressure in a coarse sand is one of the most important reasons for the development of quicksand condition. So sometimes artesian pressure develop. What is the artesian pressure? Suppose আমাৰ দুটা impervious layer আছে, তাৰ তলত যিখিনি water আছে, sometimes সেই water খিনি কি হয়, seepage flow টো বেছি হৈ যায়. যেতিয়া seepage flow টো বেছি হৈ যাব, when there is a upward flow of water, obviously there is a reason for quicksand condition, right? In clay, the shear strength of the soil does not get reduced to 0. Clay ক্ষেত্ৰত shear strength to reduce নহয় because clay ক্ষেত্ৰত cohesion extra term ahi jay. So if you draw the more column filler envelope, then you can understand there as a term called cohesion. So cohesion to thakiboi. Although hydraulic gradient to 1 hobo jabo, but cohesion is always exists, right? Hence quicksand condition does not occur in clay. Quicksand condition may occur downstream of the dam. Suppose amar eta dam ase, so hey damor downstream quicksand occur hobo pare. In the next video we'll go for the seepage. So thank you for watching. So if you understand my video, then please do comment and like and share. Thank you.